Hello guys, welcome back to my channel. Today in this video I would show you how to design a band pass filter using passive RC components. The band pass filter can be made for the audio frequency spectrum. So let's start. The band pass filter is made of the low pass filter and high pass filter cascaded with each other. So the high pass filter would be simply a resistor and a capacitor. The resistor would be connected to the ground for the high pass filter. And for the low pass filter, the capacitor would be connected to the ground and resistor would be in series. Now let's place a voltage source. Actually in this simulation we would run AC sweep, that is to plot the frequency response of the RC filter, the Bode plot, and we would also see the phase response in the same plot. So the lower cutoff frequency of the audible frequency spectrum is 20 Hz and upper cutoff frequency is 20 kHz. So for the 20 Hz, F is equal to 20 Hz is equal to, formula is 1 upon 2 pi RC. Let us assume R equals to 10 kilo ohm. So we can easily calculate C equals 1 upon 2 pi into 10k into 20. With the help of calculator you can find this. (7.95) into 10 raised to the power minus 7, or we can say 800 nanofarad. 800 nanofarad, and this is 10k. Now for the low pass filter we also suppose the same resistor value of 10k, and since the upper cutoff frequency is 1000 times larger, therefore the capacitor would be 1000 times smaller, therefore 800 picofarad. Same as 800 nanofarad, the capacitor would be 800 picofarad, 1000 times smaller, because the upper cutoff frequency is 1000 times greater than the lower cutoff. So this is the high pass filter. I inserted here comment high pass filter, and this is low pass filter. And I also put the node voltages, output node and input node. We would analyze the output node. Now let's set the voltage source. Voltage source is small signal AC instance, 1 volt AC amplitude and 0 degree phase shift. Let's say it is 1 kilohertz. Okay. Now the schematic simulation is set. Now let's press the simulate button. AC analysis. AC analysis, we would run a decade sweep with 100 points per decade, and start frequency would be 0.2, stop frequency would be 200 kilohertz, because with the multiple of 10, the 20 Hz and 20 kilohertz would lie within this range, 0.2 Hz to 200 kilohertz. Okay, now click on this pointer here. Very nice sweep curve we obtained here. Now let's check what either we got the minus 3 dB cutoff exactly at what we calculated. Here Please check this. As we move this cursor pointer to 20 Hz, it should be minus 3 dB. And yes, it is exactly equals to minus 3.00 dB at 20 Hz. Now let's see this is the lower cutoff frequency, that is high pass filter. Now for the low pass filter, the upper cutoff frequency would be 20 kilohertz. This is the 20 kilohertz frequency, and yes, it is minus 3.0 dB. Okay, now as we can see, the phase shift is also perfectly fine, minus 45 degree phase shift, and here also we would have the same phase shift but with positive sign, plus 45 degree phase shift. This dotted line is the phase, and this solid line, green line, is the amplitude gain frequency response. So I hope you learned something from this small video. Thank you for watching my video. Please like and share my video if you like it, and do subscribe to my channel. Thank you.